example 5 is on boating. I'm going to tell you this is one of my favorite examples in the section because it requires a little more than just here's the equation, find the derivative, plug it in. It actually requires a couple more steps than that. So I really, really like this problem. It means it's a really, really good test problem. So pay attention to this problem. Let's see if you understand what's going on. It says a boat is being pulled by a winch on a dock, and the winch is 12 feet above the deck of the boat. You can see this in the figure. It says the winch pulls the rope at a rate of 4 feet per second. Find the speed of the boat when 13 feet of rope is out. Okay, so what I'm going to do is extrapolate from this picture the shape. And the shape that it's making is a right triangle. And that's really important to us because what we know with right triangles is we have A, B, and we have C, right? And we know the equation a squared plus b squared equals c squared. That's a Pythagorean theorem. A squared plus b squared equals c squared. Okay, let's also look what it is. Let's think about A. A is given to us at 12. That is a fixed length. The height of that dock never changes. And if the height of the dock, remember, a derivative of something is the rate of change of something. So that is 12 feet high, and that never changes. So what's its rate of change? Its rate of change would be 0, wouldn't it? Let's look at C. They're giving us C equals 13, and they're also giving us C being the length of the rope. They also gave us C prime, right? Because the rope is being pulled. So the rate of change of the rope, what's happening to the length of the rope? Well, it's being pulled in by 4 feet per second. So technically the length is decreasing by 4 feet per second, isn't it? So shouldn't this be a -4 for -4 feet per second? That's the rate of change of the rope. Okay, so I review the problem and I try to think about this, and the question is, what is B and what is B prime? Well, B would be the distance from the boat from the dock. We don't know what that is. Well, we don't know yet, but we can figure it out. And what is B prime? Well, we certainly don't know what B prime is because B prime says find the speed of the boat. Well, that's what you want. You want B prime because remember, B prime would be what's the speed of the boat right there? How fast is the boat actually traveling? So what we want is B prime. So of these 6 things, A prime, C prime, B, and B prime, we need to know 5 of the 6 of them to be able to find the missing one. So what's the one bit of given information I don't know that I need to know is I need to find out what is B. So how do I find out what's B? Well, let's think about this triangle. Let me redraw the triangle. Again, why? I don't know. It just helps me. I know the left-hand side is 12. I know the boat is 13 feet away. And then I know that's B on the bottom. So here I can actually use Pythagorean Theorem at that given moment of time to find what B is at that given moment of time. So when I do that, I use the Pythagorean Theorem. I know 12 squared plus B squared would have to equal 13 squared. Solving for B, I'd have B is equal to the square root of 13 squared minus 12 squared. So again, I'd subtract 12 squared from both sides. I'd take the square root. Remember, when I take a square root, there's both a positive and negative answer, but the negative answer here doesn't mean anything. Go ahead and put that into your calculator, and I'm getting B has to be a value of 5. So at that exact moment, the boat is 5 feet. Let me clear that up so you can see that a little better. The boat has to be 5 feet away from the dock. Okay, remember, I take the derivative and I plug in exactly none of these values. None of these values until I've taken the derivative of both sides. So let's go back to our original equation. I'm going back to the original equation. I'm going to find the derivative with respect to t of both sides of this equation. The derivative with respect to t of both sides of these equations. When I do that, the derivative of a squared would be 2a prime plus the derivative of b squared would be 2b prime equals the derivative of c squared would be 2c prime. Okay, so what do we do at this point in time? Well, we have all the given information that we need, the 5 missing pieces of information. We know A is 12, A prime is 0, B is 5. We want to find B prime. We know C is 13 and C prime is negative 4. So I'm going to plug in all of those values. There's too many colors to try to color coordinate it for you, but I'm going to plug in all of those values over here. So it'd be 2 times A. Well, we know A is 12. Times A prime, the length or the height of that dot doesn't change, so that's a 0. We had to infer that. Plus 2 times B, we know B is 5. B prime we don't know, and that's what we want. Equals 2 times C, C is 13, times C prime, the length or the distance from the dot is decreasing by 4. And if, by the way, if you didn't put a negative sign here, you would still be fine with that. You'll see how that comes into play at the end. So what's 2 times 12 times 0? That's just 0. 2 times 5 times B prime, that would be 10B prime. 2 times 13 is 26. 26 times a negative 4 would be a negative 104. I divide both sides of this by 10. And what do I get B prime to be? B prime here would be, well, I'm getting a negative 10.4. What's the rate of change? Well, it's distance by time. So distance is feet, time is measured in seconds. So that'd be negative 10.4 feet per second. So what's the negative mean here? Remember, negative here gives us a direction. This means the distance is decreasing. So what is the speed of the boat? The speed of the boat is actually 10.4 feet per second. The negative here is just giving us a direction, meaning that it's traveling towards the boat or towards the dock. So that's all the negative means there. The real speed would be 10.4 feet per second. Okay, let's look at example 6. Example 6 says all edges of a cube are expanding at a rate of 6 centimeters per second. How fast is the volume changing when each edge is 10 centimeters? So let's think about a cube again. Remember, with a cube, when you have a cube, the length, the width, and the height are all the same. So when you do volume equals length times width times height, all of those are the same. In most textbooks, when they're all the same, they just give it the letter S, S being for side. So this would really be S times S times S. So really what we have is volume equals S cubed. So let's look at this. What's given to us? We need some given information. It says it's a rate of 6 centimeters, and it says those are the edges. So that would be what S prime is. That's the rate at which the edges are changing. It wants to know volume, what volume is changing. So it wants V prime. And then it says what the edges are. The edges are 10 centimeters. So that gives us S equals 10. So again, putting over here, what's our given information? Our given information is that S prime equals 6 and that S equals 10. Okay, go back to our equation. Volume equals the side cubed. We're going to take the derivative with respect to t of both sides. The derivative of v is v prime. The derivative of s cubed would be 3s squared times s prime. Don't forget your primes in there. We use our given information now. Again, the given information, we know that s prime equals 6, and we know that s equals 10. So what's v prime? V prime in this case would be 3 times 10 squared times 6. Go ahead and do that out on your calculator. I'm ending up with 1800. Let's be careful here. Again, this is volume. So if you think about the length of a side, that's in terms of centimeters. So it'd be centimeters times centimeters times centimeters. So that would be centimeters cubed per second. Again, area is always the unit squared per second. Volume would be the unit cubed per second, or per minute, or per hour, or per day, whatever it is. Okay, let's look at our last example here. Example 7 says the radius of a sphere is increasing at a rate of 3 inches per minute. Find the rate of change of volume when r equals 9 inches. So it wants the rate of change of volume. Rate of change of volume, it wants v prime. So what do you need to remember? You need to remember what's the volume of a sphere. Well, the formula for a volume of a sphere is 4/3 pi r cubed. If you don't have that memorized, put that on your note card for when you take that test, if you're allowed a note card. Okay, what's given to us? Well, it's giving us the radius is changing at a rate of 3. So that tells me for my given information that I have r prime equals 3. Again, the rate of change of the radius is 3. And then it also tells me what my r value is. My r value is equal to 9. Remember, we never ever plug these numbers in until we found the derivative of both sides. So let's find the derivative with respect to t of both sides of this equation. The derivative of v is just v prime. The derivative of 4/3 pi r cubed, remember pi is just a number, so this will be 4/3 pi times, well, the derivative of r cubed is just 3r squared. And then we need our r prime. Never forget your chain rule in this. Notice what happens with our 3's. It simplifies, so I'm looking at a volume of 4 pi r squared times r prime. Simply use our given information. We know that r prime is equal to 3. We know that r is equal to 9. Be very careful that you're plugging those in the right place. You want to square the right one. So I'm getting v prime, the rate of change of the volume, is 4 pi times 9 squared times 3. We'll plug those into your calculator. I don't know, how about 2 decimal points sound to you? Because this problem doesn't state what it wants us to round it to. So let's go for 2 decimal places. I'm getting 3053.63 if I round to 2 decimal places. Does that work for you? And again, for our units, it's volume, so it's going to be whatever the units were, which was inches, cubed, divided by the rate of time. So per, in this case, it's per minute. We do have to label our answers. No units, no credit. So I would have to take off points if you didn't properly label your answers. So be careful with that.